Hello everyone. Today we are going to discuss the topic Boolean algebra in Unit 5. First, let me discuss the definition of Boolean algebra. The definition of Boolean algebra is a complemented distributive lattice is called a Boolean algebra. A complemented distributive lattice. A complemented distributive lattice is called a Boolean algebra. Actually, a Boolean algebra, it satisfies some properties. With respect to three elements A, B and C, it satisfies some properties. The first property is commutative law. Actually, this one we already discussed in 4th unit also. First one, commutative law. That is, when you take two elements A, comma B belongs to the set B, A plus B is equal to B plus A. This is with respect to addition. Similarly, A dot B is equal to B dot A with respect to multiplication. Second one, associative law. For associative law, usually we are taking three elements. That will be A plus B plus C is equal to A plus B plus C. And the same with respect to product, that is A dot B dot C is equal to A dot B dot C. Third one, distributive law. Here also we are considering three different elements, but the operators are different here. In associative law, the binary operators are same, but here it is different. A plus B dot C is equal to A plus B dot A plus C. Similarly, you can rewrite like A dot B plus C is equal to A dot B plus A dot C. And fourth one is identity law. Here there exists some identity elements, that is 0, 1, which belongs to the Boolean set, that is capital B, such that A plus 0 is equal to A if 0 is the identity element, and A dot 1 is equal to A where 1 is the identity element. And the fifth one is complement law. In complement law, when you consider an element A belongs to the set B, that is capital B, there exists a complement which is A dash, which also belongs to capital B, such that A plus A dash is equal to 1 and A dot A dash is equal to 0. I repeat, A plus A dash is 1, A dot A dash is 0. So that's it, the definition of Boolean algebra. A complemented distributive lattice is called Boolean algebra, and it satisfies the above mentioned 5 properties. Next, we discuss some theorems. Theorem number 1, idempotent law. I am going to explain only the statements now. We move on to the problems directly. First one, idempotent law. As we studied already in unit 4, here also the idempotent law is defined like A plus A is equal to A and A dot A is equal to A. This is true for all A belongs to capital B. The very first theorem, that is idempotent law. Second one, in the same manner, when you consider boundedness law in the sense, we need some boundary values also here. Let me explain now. Boundedness laws. It is otherwise called as dominance laws also. Actually, the formula becomes A plus 1 is equal to 1 and A dot 0 will be 0. Here also it is true for all A belongs to capital B. And in the same manner, as we discussed in lattices, here also the complement value will be unique. Even though if you consider two different complements, you can prove both are equal. Next, third one, Absorption law. This is very important theorem. While solving problem, we require this law only actually. Absorption law. Here, your formula will be, first one, A dot of A plus B is equal to, which is A, because A is repeated here. Similarly, the second formula is A plus A dot B is equal to, if of course here it is plus, A plus A dot B is equal to A for all A comma B belongs to capital B. And the fourth one is De Morgan's law. Remember, we already studied De Morgan's law with respect to lattices also, but now we are going to study De Morgan's law using Boolean algebra concept. The first one, A plus B whole dash is equal to A dash dot B dash, and second formula is A dot B whole dash is equal to A dash plus B dash. This is true for all A comma B belongs to capital B. Using this absorption law and De Morgan's laws, we are going to solve the problem. Actually, the proof of De Morgan's law is quite similar to the proof of De Morgan's law in lattices. So, you can go through it in material. Thank you.